This video shows how the Farallon Islands disappear behind the curvature of the ocean surface. It is evidence supporting the hypothesis that the entire surface of the Earth is curved, and an experiment that can be fairly easily replicated by others. The Farallon Islands are about 27 miles off the coast of San Francisco. On most days, there is a fog bank off the coast that obscures the islands, but a few days ago the weather was clear enough to see them. I took video of the islands using my mobile phone, a Samsung Galaxy S7, with an 18x telephoto lens clipped on. I started near Ocean Beach at the intersection of Seal Rock Road and Alta Mar, which was the highest point from which I could see the islands. According to topographicmap.com, that point has an elevation of 243 feet. I then moved to a lookout point at the bottom of Seal Rock Road, then to the intersection of Point Lobos Avenue and 48th. From there, I recorded continuously as I walked down to the beach and back up again, stopping every minute or so to shoot the islands. This is the first still image, taken from the top of the hill at about 243 feet of elevation. The top half is the original video frame. I rotated it slightly so the horizon is level, since I was not holding the camera perfectly level in my hands when the frame was taken. The bottom half is the same image, except I used image processing software to increase the contrast of the islands against the sky so their shape can be more easily seen. In this image, all 4 peaks of the South Farallons are visible above the horizon. This is the next still image, taken from a lookout point a little bit below where the first image was taken. Again, I have slightly rotated the image so the horizon is level and increased the contrast in the lower half. All 4 peaks of the islands are still visible, although a small portion of what was previously visible is now hidden behind the horizon. That will be more obvious in a moment when I show the entire sequence in a loop. From here, the pattern continues, with images taken from gradually lower elevations as I walked down toward the beach. This is the last image taken on the way down. The islands have disappeared entirely behind the horizon. I'm not sure I was pointing the camera in precisely the correct direction for this shot, since I couldn't see the island anymore, but I hope you'll trust my claim that nothing was visible above the horizon at this point. The next image shows the highest peak again because I started walking back up the hill. Successive images show more and more of the island. Finally, we reach this image, the last one in the sequence, taken from Point Lobos and 48th, which is the same elevation as the third image at the start of the sequence. Now you see the full sequence in a rapid loop, so the differences between images are easier to see. The first observation is that, as I descend toward the beach, the islands disappear behind the horizon. The apparent size and shape of the islands does not change during this process. This observation is consistent with the hypothesis that the ocean surface between the beach and the islands is curved upward, blocking more and more of my view of the islands as I descend to the beach. It is inconsistent with the hypothesis that the water surface is flat, since in that case I should be able to see the full height of the island from any elevation. Second, at the point where the islands disappeared entirely, I visually estimated the height of my camera above the water to be about 20 feet. I can plug this number, along with the distance of 27 miles, into the Metabunk curvature calculator to see the predicted hidden height. The calculation without refraction yields 309 feet, which is reasonably close to the 357 feet that Wikipedia says the South Farallons are in height. Thus, the observation is quantitatively consistent with the hypothesized Earth radius of about 4,000 miles to within the precision of the measurement technique. I want to close with an acknowledgement of Wolfie6020's video showing Rottnest Island from 2 elevations side by side, which was the main inspiration for this video. See link in the description.